All right, welcome everyone. I'm going to introduce Biplav Srivastava, a friend of mine. He's a research staff member and master inventor at IBM Research and an ACM distinguished scientist and distinguished speaker. He will talk to us today about employing conversation agents and open data for a helpful real-world application universe. Thank you, Biplav.
Thank you. Thank you, Satish. Thanks for having me. And just a little word from the sponsors. So ACM is sponsoring my trip. So I'm supposed to put this slide about ACM as well as the Distinguished Speaker Program, which I'm using to come over. So this is the organization of the talk. And this is also a progression of how I have been working. So I'm going to talk about conversation agent, open data, and how to build real-world applications. And in the process, I will hope to talk about some of the AI methods that we have been employing. Also leading to fairness and bias issues that I've been beginning to investigate, and specifically also look into what are some of the optimal conversation strategies when you are using chatbots. And I was saying that this is in the reverse order is how I've been progressing as a researcher. So my PhD and all work has been in AI. Then I started looking at I should be building some real-world applications. I realized that I need data, and there's no better place to look for data than open data. And once you have that, then how do you interact with people? And that's how the conversation agent. So although the talk is top-down, as a progression, I've been looking at from bottom. Okay, so conversation agents, I'm sure everyone knows about chatbots here. Just for the purpose of level setting, they are interfaces which can be text-based or speech-based. Traditionally, they have been interacting with static information structures like data sources, database. And the uncertainty is with respect to the natural language, or it could be with respect to the human behavior. How do people speak in certain conditions? And there has been a lot of work in building dialogue management techniques, which is how automated agent talks or converses with the person. They can be reasoning based, and nowadays it is popular to have end-to-end learning based. Okay? And there's a lot of variety in between. This becomes even more interesting in dynamic environment, and the dynamicity comes because the data is changing all the time, like sensor data. So you're talking about weather, or you're talking about traffic, and to your agent, and the data keeps changing. Second is group of people. So not just a single person, but a group of people. You might be doing interviewing, and a chatbot is helping you conduct good interviews, for example. Okay. And multimodal interfaces, not just a chatbot, but there is a map, and you are working together with it. And this brings in a lot of interesting issues on dialogue management and combination of learning and reasoning and execution and so on. So I'll give a few demonstration of chatbots that we have done, and in the process kind of motivate some of the issues as well as the techniques that we have been looking at.
And New York State.
So the first example is Water Advisor.
Water Advisor is a chat-based tool for exploring large amounts of water quality data using machine learning techniques. Here we see a map of the United States. The blue dots indicate locations where the current prototype has data: Flint, Michigan, and New York State. First, let's investigate Flint. Let's look at Flint, Michigan. Now we can take a closer look at the data for Flint. I'm interested in drinking water quality. I'll ask, where is it safe to drink? The map is now color-coded based on drinking water quality. Red locations are unsafe, and green locations are safe. On the left, we also see regulations that bear on water quality. We can click on the dots to get more detail. Here we see detail for 714 Spelman Drive. We can see it's unsafe to drink. At the left, regulations that contribute to this assessment are highlighted. We can also see pollutant levels for this location. Let's look at bathing. Is it safe to bathe? The map is now color-coded based on water quality for bathing. Here is a location where it's safe to bathe. Notice that different regulations are highlighted as supporting evidence for this assessment. Now let's look at data for New York. I want to drink.
So I'll stop here in the interest of time and move to the other ones. But imagine that this is a group of people who are talking about like a Flint water issue has come in and what should we be doing. Everyone is not a water expert. Some people are health experts, some are policy experts, and so on. And now the second example is of a chatbot which is trying to talk about exoplanets, that are planets outside our solar system, and you can interact with it, know about the different things which are happening. And this is the one which so both the demos that I'm talking about, they were presented at the recent AAA.
And find patterns and relationships among them. I can even program myself to compute quantities that are not in my database.
Watson, can you show me a plot?
So what is happening is, imagine a room where an agent is, and one or more people are interacting and they are exploring exoplanets. So that's the context in which we are talking about.
Exoplanets?
Okay.
Okay, so this is stellar mass plotted against stellar temperature. Use a maximum of 12,000 and make this a log scale.
Okay.
Watson, plot stellar age against stellar temperature.
Okay.
Okay, that's interesting. We can look at the individual points which represent the exoplanets. There's data about both the planet and some properties of their host star as well. So let's go back to the original plot. Watson, plot stellar mass against stellar temperature.
Okay.
All right, now let's drill down on these data. Watson, show me exoplanets with orbital distance, mass, and radius greater than Mercury.
Here are 56 exoplanets.
Actually, I changed my mind. Watson, show me exoplanets with orbital distance less than Mercury.
Here are 554 exoplanets.
Okay, and you can see that the plot updates itself to reflect those changes. It's very useful when you're exploring data to be able to change your mind and interact very naturally with the system, which can understand that we only mean to change a piece of our query. It would be very awkward for me to give the whole query again from scratch. One important capability for embodiment is multimodal interaction. And we find that being able to point and talk at the same time is very powerful. The two modes are very synergistic with one another. Tell me more about this planet.
Okay.
Tell me more about this star.
Okay.
And so here we very easily get access to information about planets and stars simply.
So we were talking about the perception and how to use the context in the conversation. And I will point out.
It would be interesting to explore that and see what those planets are.
Excuse me, Jack.
Yes, Watson, what is it?
I have derived an.
Yeah, please.
Will you be talking about any of the details of the underlying technology?
Absolutely. Okay. So I'm trying to first give you a sense of what all issues are involved, and then I will definitely be talking about it.
For orbital distance. Would you like to see it?
Oh, yes, Watson, I would like to see the equation you derived. Could you show it to me?
I searched a solution space of approximately 661,000 possible equations. Here is a representation of the equation that best matched the data.
All right, so I can see it found that orbital period was relevant. It ignored my two other variables of stellar radius and stellar mass. So that's orbital period squared, and that's a cube root there. So Watson is finding that orbital distance is proportional to orbital period to the 2/3 power. And in fact, this is the relationship that was discovered by Johannes Kepler in the early 1600s. It took him about 15 years to discover this relationship. Watson, how did you derive this equation?
I used an experimental symbolic model discovery capability that is under development at IBM Research. It uses optimization to derive relationships that best fit numerical data. Also, thank you for your advice about relevant variables. It reduced my search space dramatically.
So this is a good example of how we can combine the best of human intelligence and machine intelligence. Had I been an astrophysicist, you can imagine me having based my suggestions about relevant variables based on my physics knowledge, and then the system could take the problem the rest of the way and solve it. Now, let's return to the similarity view over here. We had a cluster that was that had a bunch of Jupiter-like planets, and then we have this triad over here that is different from it. What's the nature of that difference? If we take a look, here we see Sol D, Sol E, Sol C. These are Venus, the Earth, and Mars. And as you know, these planets are much smaller than Jupiter, and they're much closer to their host star. So it makes, and they're very similar to one another. So it makes sense that they should be in a little triad unto themselves, away from the big Jupiter cluster. Now, if I'm an astrophysicist and I want to find objects that are unusual, I can use the system to help me identify those objects. Watson, show me the most unique exoplanets.
I've ranked exoplanets according to their uniqueness.
What Watson has done is it's put the most unique planet at the top. That's this one here. You can see that its orbital period is 47,000 days. That's about 120 or 130 years. And its planetary mass is 22 times that of Jupiter. So it's a really large planet orbiting very far away from its host star. Then you can imagine I could then go and drill down on that planet and figure out what makes it so interesting and unusual. I'm going to show you one final capability. Exoplanet data are collected from a variety of different instruments, and there's a lot of missing data, but which data fields are present and which are missing varies a lot across different exoplanets. And if I want to calculate some quantity based on those data, it's hard because there's no one formula that works across the board. But our system can handle that. Watson, calculate luminosity.
The stellar luminosity for HD 41004b in solar luminosity is 0.023875.
Watson, how did you calculate luminosity?
Here's how I calculated stellar luminosity for HD 41004b. First, I retrieved apparent magnitude, stellar distance, spectral type, and stellar temperature from the database. After that, from apparent magnitude and stellar distance, I computed absolute magnitude. Next, from absolute magnitude, spectral type, and stellar temperature, I computed volumetric magnitude. Finally, from volumetric magnitude, I computed stellar luminosity.
Watson, how did you figure out how to calculate luminosity?
I used an experimental AI planning technology from IBM Research to program myself.
So to say just a little bit more about that, what happened was when I asked the system to calculate luminosity for the star that I pointed to,
I think people in the audience know about this. But the point was data integration and query decomposition using planning. We have been doing it for a long time. And here, the system does that. The last part which I want to show, so I showed two different chatbots, one with water, one with astronomy. The third one is what we are releasing as part of a commercial product. So a very simple demo on that. And here, what you are doing is you are asking, so the context is, you are a person who's looking at a chatbot and trying to say, can you find me jobs which are similar or which are for future, right? Or if a lot of openings are there in a corporate setting, right? And you want to figure out what jobs might be good for me, what are better matches for me, and so on, right? So today, the one way is that you give search on various portals. Instead of that, the system will ask you, what are your skills? If you try to match and figure out additional skills that you might have, and then it will do search on, and then it will recommend jobs to you. So that's the setting. Now, in this simple setting, and there's no audio here. I'm sorry. So what's happening is the employee is asking for, I want to add a skill to my search, and the system says, can you describe me what skill are you looking for? There are too many skills in my database, right? And the system, any corporate system might, or a Monster or any of the job portals, right? It has thousands of skills. So the person might, I'm good at object-oriented programming. And the system says, okay, so you are talking about programming and object-oriented programming. There are 16 skills. And then it is going to notice the kind of question the system is asking. So first, it was asking an open-ended question, right? Next, it is now moved to yes-no question. So this is intelligently deciding what is the kind of question I should be asking. Given that you can ask close-ended, open-ended, binary questions, multi-choice question, and so on. So what should be the right questioning strategies? And then you use that in extended search. So I wanted to give you a sense of the kind of chatbots we are talking about. And then, as I mentioned in the beginning, I will first talk about chatbot issues, then open data issues, and some application issues, and finally some of the AI. So that's the breakdown of the talk. So first, the water, I'll take the case study of Water Advisor. Here, giving advice on water, right, is very commonplace. We go to a pond, we see something. Flint, after all the issues have happened, there is a website which tells you you cannot drink this water, but you can bathe with that water, and so on. Right? Now the problem is, all of this information, right, it is static, non-interactive, non-contextual. It is just out there. Okay. Can we use dynamically, personalized to a person's use case? Can we make it data driven? So that's the problem that we are going after. Okay. Now the other thing is, as you are doing this kind of stuff, you also have to be aware of being correct and also giving legally bound good advice. In water, drinking water, right, it is not about just lead and copper. There are 30 standards, 30 parameters at least, which are related to drinking. And I'll give an example of that. But you are just measuring 2 of them, right? And yet you are saying it's good to drink. So there's a lot of contextual information that the other parameters, they should be fine. Okay. How do you communicate those kind of information? You saw the example. It was not just a chatbot, but there was a map and there was a document which was being used as an evidence to make its point and to point out things. So the typical architecture of this kind of system, right now it is a natural query extension to a database. You may think of it as that way, but it need not be that way. It can be more complicated, as we saw in other examples. The main thing was that you had water pollution data set which was coming in. You had regulations and purpose. Now they change and they're hierarchical at multiple levels. And once you figure this out, you can get not only the recommendation, but you have to explain how you arrived at that. So we have done this demo. It was using data from Michigan, but for regulation, we were using it at a Michigan level, at US federal level, at other countries, because to arrive at a data-driven recommendation in this example. I was telling you that even a simple use case like drinking, there is a lot of parameters. We were just focusing on 2 of them. So the area is complicated, and how do you communicate the right information, accurate information, and at the same time, you can always say, I don't know, right? That's the state of the art today. So how do you move that and give meaningful response? So that's the problem. And a little more, I mean, I'll not go detail into the water thing, but more detail is available and on this use case. And there's a detailed there's a paper on this one. So there are technical issues when we get to building these kind of chatbots. So there are general issues and there are domain-specific issues. In the case of water, the general issue from a learning standpoint was learning the intent. What are you talking about? You're talking about drinking. Somewhere it's called bathing. Other place it's called something else, right? And so that's from a domain-independent form. From domain-independent learning is about water quality trends and visualization. So how do you give and represent different information? Representation is sensor data, and in water there is a specific representation issues about regulations and so on. Reasoning, multiple kinds of reasoning problems come in here, especially on handling of missing data. Execution, how do you control and execute different modules of conversation and visualization, because there are multiple modalities was there. Finally, the other things which are not there in a related area called robotics is human usability factors and ethical issues. Okay, you can give a lot of information, or with missing information, you can give information which can be perceived in a wrong way. Okay, so you have to be correct about that. And more about these ethical issues and so on is when I get to towards the end, I will talk about one such problem. So as we go there, just some final thought about when is a chatbot really appropriate and when they are not appropriate. In various discussions with people, what we have realized is that when a person wants to explore an unknown domain, right, where they don't have information, a chatbot is appropriate. Sometimes it is appropriate when you need a trace of the recommendation, what happened, so you can actually have that information. And when the person is interacting with, say, a robot, then because you expect people to talk, so physical embodiments, you want them to talk. So sometimes you have the expectation for conversation, so that's when it is appropriate. And some of the conditions where they're not appropriate, it is where the domain is static. So, and chatbot, the sequential modality is very time consuming. So if the person already knows about the domain, you don't want to be in the conversation mode. And the second one is when the domain is not changing very frequently, because the data is not changing, like a lookup table, right? You know, the employee is going to be in that office, right? It's not changing that often, and so on.
Question. I mean, there are lots of cases where chat interaction is much shorter than picking many things from menus. So if I'm an expert, I can use the jargon and express a very succinct statement that gets me the information that I want. You know, I mean, you seem to be ruling that out, or you say that if I'm an expert, chatbot's not so good.
So if you're an expert, probably, and there might be other modalities which might be much more appropriate.
But it seemed like in your case there with exoplanets, you had an expert talking to it, right? You had to be an expert to know what even the terminology meant to express those things. So
maybe we think of, we put space as or astronomy in rocket upper level. But if I take water as the example, right? You may be interested in water, but you may not be an expert. So, for example, a health professional, right, cares about water and is it good, is potable, and so on, but they may not care about individual parameters. So the thing about who the expertise level and what level is that appropriate, right, is actually so what I've realized, at least from the in various data sources that we have worked with, an expert, if they already are there, so for example, search is already available to them. Okay, so it's chatbot versus search is an open question. I think that's I'm giving an example of one modality, search, right? When is it more applicable than chatbot? And most of the experts that I've seen in many of the areas, they don't like chatbot for other reasons. One might be that it doesn't recognize their accent if it's a speech-based one, or if mistakes. typos, right? So they do not recover that well. So it's a question about capability right now. So again, there's no hard and fast rule. I'm just saying that what we have seen when people really appreciate the need for chatbot, because right now it's a buzz, and when we are talking and then realizing, looking at the data set, we realize that the value might not be that much. So think of this as just a current understanding. So what I want to end with this section is with the interfaces. They are a promising platform to integrate various AI subcomponents. It involves a lot of the areas that we have in AI, and building. There are some open issues here. One of them is testing the chatbots for their behavior, right? It's a very big open question. How do you benchmark performance? That is again a very important one. And then how do you characterize the error? So, and the error is it an error? Is it a bias? Or is it an attack? So I'm not getting into those issues, but they are very likely and big issues here. I know people here are experts in data, so I'll just quickly flip through them. But there are certain points which I just wanted to highlight. Okay, open data. For people who don't know, it is data which is free to reuse. So it's more about licensing. And it has been around. The idea is not new. What is new is that government has been putting in more data with open data policies. And of course, this is different from big data, which is all about volume, variety, and so on. There are thousands of 500 to 1,000 different catalogs of public data. I'm just impressed how this whole area has moved in the past decade. But having said that, there's a lot of data sets, applications which give you a snapshot of any system, right? They're very few. So for example, a city, if you think of that as a system, right? System of systems, a dashboard which kind of gives you a quick summary of what all is happening in a city, there haven't been too many of those things. So this is a dashboard which Amsterdam has been trying to do, of using different open data from its areas. And Tim Berners-Lee's 5-star rating of data has been around. I'm assuming that people are aware of that, so I'm just going to skip it. Something which is very unique to India is we always seem to find the corner cases to break any of the settings. So although Tim Berners-Lee came up with 1, 2, 3, 4, 5, where one was that data which is not machine processable but available, we came up with a level 0. So the way we did it was we had something called a Right to Information Act, RTI Act, where you could request government for information and that would come only to you. The government never put it on a portal. So it was not at level 0. So it was open data. Everyone could request it, but it would only come to the requester, not to the general public. So we managed a corner case there also. Anyway, so in there, one recent trend which I saw was that they are trying to actually have a chatbot for open data portals, like Kansas just started one. Okay, and what I found very interesting was on the portal, if you ask for, I just did a small experiment. You're asking for traffic data, for example, right? It points out and guides you to one of the results. On the other hand, if you just go and do a search on traffic, that particular data set is 3rd or 5th or 7th. So it is using some context of your search, right, and guiding you to some result. Okay. One may say, how come the 3rd result be the first one, right, in a chatbot when you did just the same input? So just to kind of illustrate that guided support can be useful in certain cases, but it may not be. But this is one of the areas where open data is moving towards. So what is the value of a chatbot in this kind of example? You're guiding on discovering relevant data, and the natural interface, of course, is very helpful for many because of disability and other reasons. But one can also say that there's a perception of, oh, why did my data set come as the 3rd or the 5th or so on, right? So someone can feel offended if they want to. I'll just skip some of the things. And the reason why I like open data is that although you may have choices of multiple data sources, like social data for any application, open data is among the easiest to work with to begin with, and then you can start fusing. So that's just from a practical point of view. I've been liking to work with this. And some of the issues which have been around, and people here they are experts in that. One is on semantics, data representation. Second is on scalable machine learning and contextual data visualization. Interestingly, some people from Microsoft came very recently and they said data sets should come up with data sheets. The idea being just like in electronics, right? You have a resistor or any of these devices. It comes with a data sheet. How will your data perform under a certain condition, process voltage, temperature condition? Similarly, if you're going to consume someone else's data, right, issues might come. So they came up with this notion of data sheets, which I thought was very interesting. And especially if you're going to build models and use them in different conditions, that would be relevant. I just wanted to leave with that thought. And I will talk a little bit about when you're building applications, what some of the things one should pay attention to. This is coming from, I gave it HVAC 2015 tutorial. So I've been working for about 7-8 years on water, traffic, and those areas. And the main motivation I have noticed is that what's essentially happening in a city or that kind of system of systems setting. Previously, or the traditional city that you may know of, it has siloed departments, and there might be a department of water, energy, and so on. And any IT or any of those activities would be siloed into departments, whereas the whole accountability would be from the top. Now, after they are trying to go after automation and digitization, the role of Department of Information Technology increases, and there is a big data and infrastructure piece for integrating. At the top also, there is a dashboard usually built so that someone can actually, with a responsibility, they can actually look at the what's going on in the city. And this is a big thing. So first, you have a centralization of IT and data, and then the presentation of results to people. And this has a big transformation when you're building different IT applications. So what I've noticed is that the real-world applications, you need to care about what is the value you are providing. So for example, you're bringing in a chatbot or you're bringing in a traffic recommender solution. What is the value you are providing with that new solution? And what is the data and the insight you are providing or you need to have? And finally, is that data available, the access part of it? So when we went into water, and I was talking about water pollution a moment back, the thing is, it can be useful for individuals, businesses, government institutions at various levels. Then there is this question about data, and it might be in a PDF or it might be as APIs and so on. And finally, access, it may be at different levels. The question is, whom are we targeting and what is the decision they can take with this new solution and without this new solution? So in water, there were a number of things that we actually did for, one can potentially do for wildlife and for, at different institutional users, individual users, and so on. And similarly, you could have a pattern for traffic. So the thing is, as you are building, you're thinking about a real world application area, you're thinking about a value, you're looking at the data, what are the access issues? And that's the time when you are thinking about what AI technology you are getting into. So smart cities solutions that we went for, many of the times, the main problem was on the data side, they did not have the culture of sharing or transparency with the data. And the use cases, there were not many use cases, how IT might actually be useful. So we were very surprised that And when I say we, I mean as part of IBM or as part of with government agencies or non-profits, we tried in various places. And the role of private sector is actually quite small. So government has its own strategy of putting data on the cloud and so on. So just like Google and Facebook, they have been using people's data, right? Government, they were not having their own strategy, and startups started coming in. Socrata was one example in the US. And academia and non-profits have an opportunity to step up. So I think this is the one trend which I've been seeing in this area. And when I look at universities and organizations, I keep telling them, make your own data publicly available as open data. Anyway, so I'll just...
I'm a little confused. So what are the challenges for the city? I don't quite follow what you think the issues are.
So the challenges with the city are, number one, one is they don't have an IT architect as such. So data is controlled to them, right? So many times they, so here's the thing. There is a water department, you might have electricity department, and you might have similarly other departments, right? You have the same road, okay? Each department will have a representation of the road in their own system in a different way. To have a single representation of the road, right, could be a challenge. So if there is an accident which leads to a pipeline burst, right, it hits the electricity pole, and then something else happens, maybe they have to shut down, and then there is a water pipeline also which gets affected. Multiple departments are involved, but everyone doesn't have a single representation of that road and the incident. So that leads to whatever time was needed, right, to remove things. So for example, to clean up that area doesn't happen because everyone, although it was reported, it doesn't percolate down to the IT systems, and they cannot take the data-driven decision that they need to. So that's typically the problem. And it is more of a policy, and it is more of getting the things together and driving a single view. So if they started from scratch and they had never probably had a data architect kind of do everything, and this is the way we will start. So I already talked about some of the issues from a chatbot setting, and I'm going to motivate a little bit on two issues that we have been looking at. Okay, and right now the way I'm thinking is, you take an application area, you think about the data sources, you think about what value you're providing people, and as you are doing it, okay, what so I'm going to actually talk about two things. One is, how do you remove a perception of bias, okay, from the results which are coming out? And the second thing I'm going to talk about is conversation strategy. And I will try to motivate a couple of techniques in each one of them. Okay. So the first one is AI services, things like language translators. We are all aware of that. From image, you're trying to figure out whether someone has a cancer or not. Image caption generator, right? From an image, you're trying to say what all is there in the picture. So all of them, they can actually exhibit biases. And biases might be that if someone is not able to recognize one kind of religious structure, but can always identify another kind of religious structure, right? Someone may say, hey, you have a bias service. Or if image service is able to figure out people of a certain color or whatever, right, but not others. In one recent example, which got a lot of press and so on, was white male APIs, image detection APIs, commercial ones, they could detect with the 3% or 0.3% error, but black females, it would recognize with 35%, right? So now the question is there a systematic bias or not? And interestingly, what happens is, as you start combining applications together. So one example is, I might be a person who loves Twitter. I write some tweet, right? And then it gets posted on 10 languages on Twitter, right? And then there is another guy who looks at that, and then they again tweet on their own site, right? Now suppose you have taken from English, and all you did was you just know English, right? But it was tweeted in 10 languages. From those 10 languages, again, it got back transcribed back to English now, right? Are you seeing the same thing? So it might be the case that you did not. So we did some experiments on that, okay? And so this issue of compositionality of services, right, is very common. From the image, so another example is I might be captioning, I've just written a tweet with a photo, right? And the service offered to generate a text for me. And then it gets translated into this 10 example that I told you. So you have a caption generator and a translator, okay? So in these kind of settings, what happens is, I'll just show some example. And this is very small, so I'm sorry, you cannot look at this one. But something like, he's a nurse, she's an optician, okay? We looked at that, and the process was went from English to a middle language back to English, okay? And sentences of the kind that we are doing gender experiments, so he or she, the third A in the third person, and a profession, okay? So, and it's of two, each test case has two sentences. The reason is that we can see what is the distribution of the gender. Okay. So in that setting, we kind of considered 8 languages, including Turkish, Hindi, your French, Italian, Arabic, so on, and the 2 commercial APIs. But now we have extended to other translators as well. And what we noticed was that the gender was going all over the, okay. And to understand that, is this a error? Is this a bias? Or what else is going on? Okay. So we said that we need to rate AI services. So there are many people who have said, let's try to fix the problem. But I think fixing the problem needs understanding of the problem. And our take is, let's try to rate services. And as you are combining things, let the rating work with the composition as well. So that someone who's consuming someone's APIs, right, they can better advertise it. That look, these are the things to be watchful about. So we are using ratings as a way of labeling. So in this example, what we have is a 3-level rating, where the rating could be, we take your AI service, we give a rating like unbiased compensating system, which means that the system, you give me a specification of what is biased and what is non-biased, the system will give its output unbiased, and to do that, it may actually act biased, but its output will be unbiased based on the distribution. The second one is data sensitive bias, which means that the system just follows the data. If the data is biased, its output will be biased. If it is unbiased, it will be non-biased. And the last one is a bias system, which really means that regardless of what is the input, the output will be biased from your specification. So the setup that we have is, you have APIs, different translators. You need to give the what is meant by unbiased specification and biased specification. So unbiased specification means that you want 50% male and female. That's what you expect. Output could be of anything, he, she, and others. So other captures the fact that you may not be able to capture either of the 2 genders, or it might be error. So in this kind of setup, we looked at how the different translators are working, and we could do it at the language level, and we could do it as an aggregate thing. So the point was, if I give an unbiased input, so something like he's a cleaner, she's a artist, something like that, what you would expect is that the output, right, when you go from English to a middle language and back to English, you should be following the same distribution. So the output really should be 0. Okay, there should be no mismatch of the gender. What we noticed was the different translators, they were actually messing up with the gender. And there are languages like Turkish and Hindi, which do not distinguish between the genders in the third person. So they were expected to give problems, but others were not. And interestingly, one API, one translator, the most Google, was giving problems with Italian, where it should not be, because there are separate words for the gender in the third person, right? And so on. So whereas the other one had no problem. Okay, so we kind of looked at various corner cases in this, and the point is we have a third. So we are not looking at the training data from the AI service provider. We ask for the specification as a third-party service. You can test them, and then you can rate them. And interestingly, and it's a two-step procedure. That's what I'm kind of showing it. The detail is in a paper we had at the AI ethics conference. And I mean, there's more detail about how we actually calculate and so on. I will not go into more detail of that. But this also works in composition setting. So not only you can do it for a single service, but you can do it for multiple services. Some of our recent work is on extending this framework to image services and text services. So that's what we are exploring right now.
So what does it mean to compensate for bias?
What it means is that the system is aware of the gender that is being measured, and then it will itself flip randomly the output. So that could be one way of doing it.
Okay, seems weird.
Seems weird. Yeah.
I mean,
but because the thing is, if you are not getting enough sampling, right? So this is not our testing framework is not going to do it. But one way to implement a translator, right? And if you know that my training data is biased, right, or it's not correct, you may just probabilistically try to flip it. That could be one way of doing it.
You assume co-reference resolution, so that the same pronoun refers to the same. Like, you've heard of these people who read their, like read The Lord of the Rings to their daughter with the pronouns, right? But they are consistent in the way pronouns are sorted.
Actually, one thing which I did not say here was I did not talk about the specific bias specification. There are multiple ways bias is defined. One is called individual measure, one is called group measure. I'm using a statistical group measure. So there is an individual measure also, which I'm not accounting for here. So what it means is that the aggregate distribution of the gender, right, which was there in the input, I'm just expecting that. There is another definition which is looking at how individual case is getting changed. So I can change what if the sentence was flipped from he to she, right? What happened to that case? So I'm not, and that error characterization is a little more tricky. So I didn't talk about that stability here. Okay. And the second thing which I wanted to quickly talk about in the next 2-3 minutes is what is the conversation strategy? Okay. So I kind of started saying that a chatbot can ask open-ended questions, close-ended question, yes/no question, and so on. Now, which strategy should one use? So a close-ended one is what industry do you want to work in? Any location preference, right? Now you can ask feature at a time in these kind of settings, okay? And the open-ended is tell me about what you care about in the work, okay? Now, which should you use? Now there's different cognitive load that you are imposing, but the other thing is the person when you answer when he or she answers, right, you should be able to process it. Now there are cases when your own components, your own NLU, if I'm an agent, I'm not able to recognize the intent correctly. Now what should I do? So if I'm not able to recognize correctly, then probably I should ask very limited questions with a limited intent so that I can recognize them with higher accuracy. Okay? So how can we model these kind of behavior in the chatbot? So the idea is that this is a targeted, a goal-driven question answering. You want to reduce the dialogue length and you want to have a more engaged conversation. So these are our goals. Okay. Now, given this, what we did was we came up with a framework for adaptive questioning answering selection, which can alternate between open-ended and close-ended. Close-ended has already been studied in the literature and it has been done using information gain. So the question was, how do you do that with open-ended? And this can actually, the experimental setup considers user behavior about the accuracy of the NLP, which is very important in practice. You can't recognize the intent, and the different traits of the item features. So you may talk about one thing, right? Then I should not be asking about related feature. So that's another way of reducing the dialogue. So I will not go into how the calculation happened. We had a paper in IUI 2018. It goes into more detail on this. But I'll talk about give away the main things. Takeaways are that you ask more open-ended questions with more cooperative users who are telling you more features, right? If the person is telling you more features at a time, then you ask more open-ended questions. The other one is that you stick with close-ended questioning if your NLP performance is bad. So we could model the lambda corresponds to what is the correct rate. With more dispersed IG across features, need to ask more close-ended questions and have more longer dialogues. And if you have more correlating features, right, then your information gain is getting overestimated. So that's the time when you are going for more adaptive strategies. Right now, what we are doing is we are modeling this. We are doing some further work here, where we are looking at optimizing we are trying to balance the near-term and long-term conversation. So our objective. So if you are answering more in the near term, right, and we have an estimation of the dialogue length. So how can we balance different questioning? So it's a sequential decision making and how we optimize performance over the expected length of the dialogue. So there's some work we are doing.
I'm curious about the NLP extraction being underperforming, how you detect that. Is that something that you sort of statically determine for whatever technology you're using, or are you sort of dynamically determining that, oh, this is a question that we're not?
Okay. So the current result was simulation result, but in practice, how you could detect it is that the person is asking questions. No, this is not what I meant. So you would look for those detectors, and then you would realize that you're not doing well. Currently, this was a simulation result, so we were just modeling it out. So just to wrap up, the things which I tried to kind of convey was conversation agents are powerful platforms for delivering decision support to people. And there are issues here, apart from what we had in robotics about planning and execution. It is all about human factors and how to incorporate them in the conversation. Open data is important and is easier to use with, and I've been always worried about where is the data coming from, especially from in a research institution. I've been always worried about this. The next thing is when you're building real-world applications, where should you pay attention to? So the value and having human in the loop of testing has been very important. So that's why I tried to spend some time about that. And I think this is a fertile area of interdisciplinary AI research. So thank you.
I had a question about the definition of chatbot. To me, Siri is a chatbot, and sometimes Google is a chatbot because I can say, how much is $1 in Mexican pesos, and it gives me the answer. But there's not. Those don't have extended dialogues. It's not like this. This phone thing is frustrating.
Right.
So are those also chatbots? Is there a taxonomy of chatbots that distinguishes your Google question answering, your one-shot question? I just type what I want to know, and it gives me an answer. Same with Siri, except for maybe a clarification question, and there's no dialogue going on. I don't want to dialogue with Google. So is there some kind of taxonomy of this?
So broadly, there are a few categories that people talk about. One is chit-chat versus task-oriented. And in task-oriented, there are question answering versus, which is one-turn conversation. And the second one is longer conversation. Now, there is another variety, which is how many participants and what their roles are. So there's a whole area about dialogue apps. And so to give an example, when you are asking a question on a forum, like Ubuntu forum and so on, right? your questioning can have no response, can have multiple responses, right? And the role of each one of the people, right? Someone can be asking follow-on questions, someone can be answering. So it becomes a little complicated there, right? So we tried to characterize this in one work where we talked about dialogue complexity, looking into, so there is a paper on archive we have on that. But I think broadly what people understand is chit chat, question answering, and multi-turn. But there's more set related to that.
I have a question about the water advisor use case you were describing. And one of the areas was you have to give an answer that's sort of relative to current regulation. So if somebody asks, is this safe to drink, this actually means something with respect to might be local regulations and whatnot. And you might have to do some inference to figure that out. So I was just trying to understand what complexity. So actually modeling what's in regulations is sort of hard to do.
Yeah.
Even if you do it manually. So are you actually doing that? Are you actually taking a whole body of regulations and sort of coding this in some work and then
Right. So actually that is the part which I kind of skipped. But so the one on the right hand side is a mapping made available on GitHub. That's what I was trying to refer to. So what Sandeep actually did, and I did, was we had a precursor mobile app called Ganga Watch, which was we looked at activities and the relevant water parameters. We encoded that in a JSON file. We manually did the mapping. We also, and I extended it, and I looked at more regulations in the US. And those mappings are actually encoded in the JSON file. And that is what we have put on GitHub. Others can use and build on it. So this was done manually. And back to your question, can it be done automatically? The thing is, or maybe you were trying to infer whether it could be done automatically. The regulations, they are actually in different ways. The same information can be captured in three different, for example, the bacterial information, how much bacterial count can be there, is represented in three alternative ways in the New York regulation. So my understanding of automated regulation reading and that kind of literature is that one, we don't have enough volume of data that it kind of justifies current methods. The other thing is, I think for accuracy, you can just read it. And so for now, what we did was we manually did it, and we made it available as a reusable resource.
Okay. Well, so a second related question might be that, then what's in the regulations might not directly correspond to what's actually measured in your data.
Absolutely. Absolutely. So in fact, so that's what I was trying to say about missing data. So, and what do you do with the missing data? So in that case, what we, so the way we give our recommendation, you have to be a little careful. Now the thing is, if I take the Flint example in EPA, it just says that water which is coming in the tap, right? Don't drink it, but do these kind of things. It is not considering all the different, all the parameters. It's just considering copper and lead. Copper and lead, yeah. Copper and lead. Now, how do I actually account for that? How do I say this, right? So that's a very tricky thing. So in fact, we had a lot of discussion with the lawyers because we were trying to put this out, and the current setting is that we have developed it with inputs from a research institute, from a water research institute. But for putting it out, you have to be very careful because it's it's all the green dots. How do I kind of interpret that? So it's a very tricky thing, and part of the answer is maybe don't say it but show it. Yeah.
I see that both the systems that you showed for the water and for the exoplanet exploration have some means of explanation, right? Could you elaborate what is the role of provenance, or whether whether you use kind of the same mechanism to explain things in both systems? Is this related like to a particular system? Can you elaborate a little bit on that?
It's a good question. Right now, I think our explanation generation has been ad hoc. okay, in both the settings. Because in water, the way you show the explanation is by just showing the regulation and saying that this is the condition, right? In astronomy, it is more complicated because you have to say that, look, these are the things which are involved in the expression, and this is, we used to have to use a planner to kind of show the trace, the dependency graph here to show, right? So it was a little more complicated, and I would say that, so right now it was ad hoc. So we know the factors, but how to kind of bring them together in a systematic way, we have not done that.
All right, any other questions?
I just wanted to ask about, you mentioned that in some systems you are aware that there is a bias in data. Maybe this is not relevant, but I'm not sure how you figure out whether you have a bias or whether that is context. Like, how do you distinguish between the two?
So you're asking a very difficult question, and we're trying to figure out how to, and not just us, but many people in this area, they're trying to figure out how to characterize error versus bias, and that's what I was trying to point out. And if it is a inverse function you can create, right, then it's slightly easier, but otherwise it's very difficult. So I wish, but I don't have a general answer for how to characterize it as yet.
So is it just manually map everything else?
So,
like for the factors that we are aware that most probably are biased, we just account for those factors.
Okay, so I should be more formal. So we know that what are the variables that people care about, which are like predicted variables, like the gender or religion or whatever, right? So we are aware of that. The second thing is there are some established definitions in the computer science community about what constitutes bias. So, for example, disparate impact is one of the things. In structured data context, right, this is understood in this way that if there was a loan approval and the data for one person, right, by just changing one of the predicted variables value, if the decision gets flipped, right, then that might actually constitute a discrimination condition. Now there is a difference between discrimination and bias. You can actually have a random discrimination, but if it's systematic, then it constitutes bias. Okay, so there are conditions which are understood and how to do it in the case of structured data. For unstructured data, it becomes a little more tricky. Okay, so that's why I was just saying that for unstructured data, which is what the chatbot setting is about, it's a little more complicated, but in the structured data, there is a better understanding. So it's a very hot topic.
Sorry. I don't know if it's structured or unstructured. I mean, there are things you have bias in society, and if your data is learned over, I mean, I don't know, if you look at people who are incarcerated, if people from a particular race are incarcerated more often, and your algorithm learns that, I mean, there's not much you can do.
So absolutely.
I mean, well, there's much. I mean, there's things you could do, but you have to do with the data you're in.
So I think
so you have to be very careful.
Exactly. So that's why we think that doing a rating of the bias, right, and annotating your service with that is a useful thing, because then the consumer, the developer, right, is aware of this service has this pitfall. So when they are actually building an application, right, they might be testing for it or they might be advertising it appropriately. So that context can be better communicated, because sometimes you cannot do with that bias, right? And maybe that's the case. Because, so I'll give a concrete example, word embedding. Everyone is using word embeddings. They are known to be biased. Now, am I going to drop word embedding in my application? No. If I have to develop something and it's going to be used, right, word embedding is available, I will put it. But I'll say, watch out for these issues which are well known.
Okay, so let's thank the speaker once again and wrap it up.